Hello, this is Mrs. Davis. I'm teaching AP Calculus. This is lesson 7.2, Verifying Solutions of Differential Equations, and this is the start of the third video, and we're on the third page of the notes. We're going to do another example. Why don't you give this one a try and come back and check out if you got the same thing, okay? And if not, play it and see why. So it wants us to find, this is again, find the particular solution of this differential equation. So we'll take the integral of dy dx, and that's going to be the integral of 3x squared minus 12x cubed dx. So that'd be y equals x cubed minus 3x to the fourth plus c. And then I'm going to use 2, negative 3. Negative 3 is 2 cubed minus 3 times 2 to the fourth plus c. So negative 3 is 8 minus 48 plus c. So that would be 37 equals c. So y is equal to x to the third minus 3x to the fourth plus 37. There you go. There's a particular solution at that point. All right. Now, of course, things get a little more difficult when they ask us for, they give us the differential equation for a second degree, and they want the particular solution, and they give you y prime at 1 is 7/6, and y of 1 is 0. So the key to this is stay organized, okay? You got to really make sure, because you're going to have to get all the way to y, and there's not that much room. So we may go down, we have more room here, so we may go down to there. It's like what I did on my notes, but I'll write small. So the first thing we want to do is we're going to rewrite this, or take the integral of both sides. The integral of 2t 2 dy dx2 is equal to the integral of x to the negative 2, I just rewrote that, plus 1 minus 2x quantity squared, and it looks like we're going to have u substitution in here, dx. So now we have to integrate this. Now the integral of the second derivative is the first derivative. So this would just be dy dx is equal to, and that would be negative 1 over x. And then, we don't know what's happening here. So let's go and make our u substitution. So u equals 1 minus 2x. So du is negative 2 dx. So dx is du over negative 2. So we have a minus 1/2, okay? Let's do this integral. We still have the integral here, u squared du. So we have dy dx equals negative 1 over x minus 1/2 times 1/3 u cubed plus c. So dy dx is equal to negative 1 over x minus 1/6 1 minus 2x quantity third to 3 plus c. So we need to find this c. So here's our y prime point, 1, 7, 6, we have 7, 6 is equal to negative 1 over 1, so that'd be negative 1 minus 1/6 times 1 minus 2, so that'd be negative 1 cubed plus c. So 7/6 is negative 1, that would be minus 1/6 plus c. This would be, hang on a minute, this right here would be a negative 1, right? And if I have a negative times a negative, that becomes a positive. So I get 7, 6 equals negative 5, 6 plus C. So C is 12 over 6, or 2. So now we have dy dx, or y prime. Well, let's use what they started using dy. So we have, let's rewrite it. Dy dx is equal to, what did we get here? Right here. Negative 1 over x minus 1, 6, 1 minus 2x, quantity third, plus 2. All right, so now we're going to integrate both sides here. So dy dx, we're on our second step. Let's kind of circle that one. Equals the integral of negative 1 over x minus 1, 6, 1 minus 2x cubed plus 2. And that whole thing is dx. And so we're going to need u substitution here. Well, let's split this guy up. So we have y equals the integral of x to the negative 1, and then minus the integral of, put that 1, 6 out there, 1 minus 2x quantity cubed, plus the integral of 2 dx. So we have y equals and by the way, this is negative 1 over x to the negative 1. So negative ln of x minus, and I'm going to keep this here still because I'm going to use u substitution, so I'm just going to get everything else, all my other ducks in a row, plus 2x plus c. So now I am going to let u equal 1 minus 2x. Well, I already did it, so I'm going to do the same thing. So dx is du over negative 2. So that means that I have negative ln of x minus 1/12. But it was a negative 2 on the bottom, so it'd be plus 1/12 integral of u cubed du plus 2x plus c. So I have y equals negative ln of x plus 1/2 of 1 minus 2x. I didn't take the integral. Okay, got to do that. 1/2 times 1/4 u to the 4th, right? Plus 2x plus c. So negative ln of x plus 1/8, right? Wait, did I have this as 1? This was supposed to be way back here. Remember I pulled the du, when I did the du, it was supposed to be 2, and so this is supposed to be 12 this whole time. And so now it is, and I hope you got that. You probably did. I just had written a 2 instead of a 12. 48. 1 over 48 u to the 4th, so that's 1 minus 2x to the 4th plus 2x plus c. Okay, so that's my general solution. And so now I put at the point 1, 0. I get 0 equals negative ln of 1, which we know is 0, plus 1 over 48 times negative 1 to the 4th plus 2 plus c. So 0 equals 0 plus 1 over 48 plus 96 over 48 plus c. So c is negative 97 over 48. Okay, and so I'm just going to write our particular solution now with that c. So we have y equals negative ln of x plus 1 over 48, 1 minus 2x to the fourth, plus 2x minus 97 over 48. Okay? So that's going to be your particular solution. So second derivative, asking for the particular solution to this going all the way out to y is going to be quite lengthy in time to do, and you have to be really organized. All right, let's do this last one. It's nowhere near as bad, okay? It says, another way to ask if you have to find a missing k. What value of k, if any, will y equal k e to negative 4x be a solution to the differential equation y prime prime? So this is like the very beginning when we were validating that was working, but we have to find k this time. But the process is going to be the same. We need y prime, and we really need y prime prime. So first we have to find y prime. Y prime would equal negative 4 k e to the negative 4x minus 10 cosine of 5x. Just taking the derivative. And so y prime prime would equal 16 k e to the negative 4x minus, but plus, I'm going to take the derivative of cosine, which is negative sine, so plus 50 sine of 5x. So I'm going to put this into there, and then it has to equal 82, so we should be able to find k. So 16 k e to the negative 4x plus 50 sine of 5x has to be equal to, oops, not yet. That was just y prime, and then I have plus 25y, so plus 25, and y was k e to the negative 4x minus 2 sine 5x. Okay, and that has to equal negative 82 e to the negative 4x. Okay, so let's see. We have 16 k e to the negative 4x plus, check this out. I think these cross out, but this was 50 sine of 5x plus, let's multiply this through, 25 k e to the negative 4x minus 50 sine of 5x equals negative 82 e to the negative 4x. So our 50s cross out. So we have 16 k e to the negative 4x plus 25 k e to the negative 4x has to be equal negative 82 e to the negative 4x. Okay, so this would be 41 k e to the negative 4x is negative 82 e to the negative 4x. So we can get rid of the e's to the negative 4x's. So we have 41k equals negative 82, so k is negative 2. And we found k. All right, that ends the lesson for 7.2.